And for all these companies, for example, for Samsung, for Apple, etc., for them it's a way of like mitigating the cost. There's multiple. Everyone puts in a little money, and then we do the research for them, etc. So that's a bit about ARM. I have a kind of interesting background. I'm currently an embedded engineer, but before that, I used to be a web developer for the longest time. I'm still a Google developer expert for web. Before I joined ARM, I was a core operating system engineer for Firefox OS. Awesome. Now defunct, unfortunately. And as a web developer who moved to being like an embedded developer, I still like to do things that are like on this edge. You know, I want to combine stuff that happens in the physical world with stuff that we can do on the web or stuff that we can do on mobile phones, etc. So if I'm thinking about developers, well, everyone sitting in this room, I'm thinking a little bit about this. I mean, you guys, everyone is so focused on what's happening on that mobile phone. You know, we're thinking about how can we optimize the speed that something renders, or how can we add new features here. But we're really looking just at a little box that's sitting in your pocket, or the laptop that's standing on your desk. It's kind of a limited worldview in that sense. I mean, the world is way bigger than your pocket, right? We want to interact with the physical world way more, and we kind of try to emulate that on mobile phones. I mean, we've added sensors, we've added GPS, but it's still very limited. It's still really focused on this little box that's sitting in your hand. And we see the same with the internet. We've got internet everywhere, and everything is connected. But when you're standing I saw that yesterday at the after party. When you're standing there and you're looking around and you see people interacting with their devices, every time they're looking up something on their phone, it's like half the time it's communication with other humans. Everything that we do on the internet needs to be consumed by someone else. Someone needs to like take the device out, read the information that gets there, or the information that you sent there. And if we want to do this Internet of Things, and that's what kind of excites me about the whole IoT movement, is that we're going to transform that from an internet of humans, an internet where humans need to interact with devices to get some meaningful information, to an internet of devices, where devices can talk to each other, exchange information, and a human does not have to interact in that whole process. The whole IoT movement, it's a bit of a hype machine at the moment. Got a little bit of a bad name. There's a whole Twitter account, actually. The internet shit, it is absolutely my favorite Twitter account. You see fantastic inventions, like for example the reset plug, which monitors whether your Wi-Fi died and resets your router automatically, or the smart toilet roll, which will tweet whenever you're out of toilet paper. You know, this whole industry, I mean, the whole IoT movement is way bigger. In my previous job, I worked in Telenor. Telenor is a Norwegian telco, and in there we ran a number of IoT projects, and one of the things we did was make a smart office. So we augmented all the toilet doors with door sensors, which automatically counted how often a door was opened and closed. And by doing that, it allowed us to send cleaning staff more efficiently through the building, because we knew which toilets needed to be cleaned and which toilets were still fresh. And these sensors are relatively cheap. These sensors don't require maintenance. They don't require a human to interact with that. You put them into the system, and the system can then determine, oh, that toilet apparently has been used a lot. I'm going to dispatch someone else. It's a true Internet of Things, an Internet of Devices. No human needs to check that out and see the data feed and do anything with that. And starting to be cost efficient pretty quickly as well, because if you can save one cleaning staff just by providing a bunch of sensors in your building, the whole cost of the system you basically already earned back. Similar, if a meeting room is smart, it can let you know if you're standing in front of it. And Like who works in an office here? How often have you walked around the office and you're like, I need to find an empty meeting room, but where the hell would that be? Yeah, this is one of my biggest problems. And then even if you see a meeting room that's empty, like, okay, so it's empty now, but is it actually unbooked? Or is someone coming in 10 minutes and kicking me out? Now, what if that meeting room is smart and tells me whenever I walk in, hey dude, in 10 minutes someone else is coming, so don't go in here. Or whenever I walk in, it says, okay, yeah, I booked it under your name now, and now everyone knows that. So if you wanna go further, and if you wanna get involved yourself in doing IoT, there's 3 things that we need to solve at this point. The first thing is, like, how can we build smart devices? The requirements of a smart device is completely different than that of a normal web application or a normal mobile application. We need to have software that runs years on a battery. It's a weird combination of hardware and software as well. And the second thing is, even if there is a smart device around you, you build a smart device, you put it in your office, like, how do people even know that it's there? How do I know that a meeting room is smart and not dumb? Or how do I know that this water bottle is connected? I don't know. You have to, like, physically interact with it, see it, see if there's a manufacturer. And then the last thing, how can I interact with these devices? So even if I know that a meeting room is smart, or that my toilet knows how often it's being used, I need to know who the manufacturer is and where I can install the application, stuff like that. So those are the 3 problems that we're going to talk about. After that, we're going to do a whole bunch of demos. As you can see, I brought a lot of peripherals and lights and stuff. But let's start with number 2, discovering devices. It's kind of hard to discover devices right now, and Google realized that as well. And Google started a project called the Physical Web. Scott Jensen, a former UX designer in Google, is now the head of this project, and his motto here is walk up and use anything. It's pretty awesome. The idea is that the physical web is like a QR code that works up to 50 meters from a point. So it allows you to give ordinary objects all around you, from people to the screen here to my laptop, give that a URL. And the URL is already a unique resource locator, and why not, like, also do that in the physical space? So they achieved that by using a Bluetooth Low Energy beacon. BLE beacons are pretty amazing. So first of all, they're incredibly small. I got one here. It's a full BLE beacon with a Bluetooth chip, something you can just buy straight away right now. And their battery consumption, their power consumption, is incredibly low. So a beacon like this can run 7 years on an AA battery, just broadcasting, sitting somewhere here, saying, hey, I'm here, I'm here, I'm here. So Google figured, hey, that's a pretty good idea. What if we use the Eddystone protocol, that's something they invented, and embed URLs in these beacons. So a beacon can sit here on a wall and then broadcast, hey, I'm CodeFestRU/Beamer3. Every second. Just a little ping. Just a one-way communication. It's not two-way, just a one-way communication ping every second for 7 years on a single battery charge. It's pretty amazing. So if you got a movie poster, and if you got a movie poster sitting somewhere and you figure, well, now I want to know more about this movie, there can be a Bluetooth beacon on there broadcasting a URL to your local cinema with the playtimes, or a quick way of doing a reservation. Similar, a parking meter in the city, if you're standing in front of it, you can get your phone, it can broadcast the beacon to a place where you can, like, actually book that parking spot. After the beacon, so the nice thing here is that because Google has very tight integration with all of your phones here, what they can do is that they integrate in the home screen or in the lock screen of your phone, and whenever you're near one of those Eddystone beacons, if you're near the physical web, it will automatically pop up on your phone and say, hey, you're near this movie poster. You want to know more? Click on this link. And then you just hit that page and you enter the web page. It's quite straightforward. The really cool thing now here is that since the day before yesterday, the physical web has been enabled on all Chrome instances on mobile. So if you have Chrome for Android or Chrome for iOS, and you've updated to the latest version, you get physical web and the discovery of beacons like straight, completely for free. And I mean, we're gonna see like a huge advent of that now. Because now there's suddenly 500, 600 million people, because that's Chrome's install base, that are going to be able to discover beacons all around you. This is a pretty powerful concept. You can just take anything, slap a beacon on it, and now it's discoverable for the whole world. It's pretty amazing. It's also very cheap. The beacon that I have here costed $4 at Alibaba. That's the complete package, so that's the beacon, a battery, and like a little casing around it. If you just want the chipset, it's about $2. And it combines both the Bluetooth chip and the actual processor. So this is here already, since a couple of days. And cheap. Now the second problem that we have is, so even if we can discover devices around us, there's still the problem of interactivity. Because if I can just see, like, oh, there's a movie poster, and well, okay, so here's the movie times, yes, so what? In the end, it's just a QR code. A nice QR code that works from a distance, but still like a QR code. Now, Bluetooth Low Energy, which we use for the beacons, is more than just sending out a URL whenever they're there, or a package every second. Let's say that we have a heart rate monitor. A heart rate monitor can advertise a URL or advertise a package every second, but you can also connect to it. And then beacons have services and characteristics. So for example, a battery service as part of a heart rate monitor, as well as a heart rate service. And those have characteristics. So a battery service can have percentage, like how much do I have left, the capacity of the battery, and the heart rate service can have the current heart rate and the maximum detectable heart rate. This is a pattern you'll see on every Bluetooth Low Energy device. If you get a parrot drone, I got one of those, really fun, about $100. You can fly them, they come with a little camera in them, etc. Pretty amazing technology. Also uses Bluetooth Low Energy and also uses a similar thing with services and characteristics. So for example, what I have here is a device that's configured as a heart rate monitor. Whenever I connect to it and I subscribe to the current heart rate, you'll see that currently 117, 118, 119, 120, just being fake. So services, characteristics. You don't really need to remember this, but we'll do a demo in a sec, and then it's kind of going to make sense if you know this abstraction. Now the cool thing is that Google is also adding support for BLE services and BLE characteristics to Google Chrome for Android. So if you're having a phone that runs Android 6 or higher at this moment, and you install Chrome, the development channel, you can interact with all kinds of Bluetooth devices straight from your browser. No app required, just a normal website. For example, this is how we do that on Chrome for Android. It asks which device do you want to connect to, and then this is all from JavaScript, no application required, and then you can like send data back and forth. The really powerful thing here is if we combine the physical web and web Bluetooth, because then I can use physical web to see that a smart device is around me. I tap it, I go to a web application, and on the web application I can suddenly interact with that device. Right? So this is how I can fly a drone nowadays. So first of all, I'm tapping on my home screen to find beacons around me. I find the parrot drone. Whenever I hit that, it opens a web application that can then actually fly the drone. So then I hit connect, or I hit fly, and suddenly the thing flies. So you can go from discovery to actual flying of a drone within like 7 seconds. You don't need to know who the manufacturer is. You can also crash it, by the way. You'll see that in a sec. You can go from discoverability to interactivity with the device within 7 seconds. Here we go, here we go. There we go. It's an incredibly powerful concept because all the time normally when you're thinking, okay, so I bought this smart device and now I need to install an app. And which app do I actually need to install? That's things that we can basically mitigate by leveraging these two technologies that Google is now launching as part of Google Chrome for Android. I'm very happy with that. Okay, so discoverability, interactivity, that's one. But this still only applies to devices that we actually bought. Like, what if we want to program devices ourselves? Well, I've been an embedded developer for a while, and if you think about the embedded landscape, especially if you compare it to the web world, but also kind of to the Android and iOS world, is that embedded is incredibly unstreamlined. If you buy a chip from a vendor, it's probably you can only run it on Windows. You can only do your development there. There's no code sharing. There's nothing like GitHub or anything. In that sense, there's a lack of libraries, a lack of documentation. Well, and here's what ARM kicks in. So, as I explained, ARM does not make its own chips. ARM works together with all the semiconductor companies in the world, more or less. We design IP, intellectual property. We design new processor architectures, and then we share that with the rest of the world for money. Of course. So we figured if we do, we wanted to unify this. So we started the Mbed project. Mbed is a way of programming ARM-based processors in a straightforward way that's also standard over all the devices that you can buy. So if this is one of the chips this is one of the boards that is one of our chips. Same development environment is when I'm using one of these that I have in the front, or one of all these other things. We currently have 91 boards supported. We got 200 people working on this full time, and we got a developer base of 170,000 developers. There's quite a lot actually. So it's an embedded platform. It consists of an operating system for microcontrollers. So if you want to program a microcontroller, if you want to get started on Bluetooth, take one of the boards that we're supported, because we know how to build for these microcontrollers. We got rock solid libraries. We're going to use it in a sec, and we got a rock solid Bluetooth stack. So, because today I also want to build a little bit of an IoT device, this is for me a very obvious choice. We also have stories of going from prototype to hardware. So, for example, this is the wearable reference design that we made. You can download this for free. We got electronics, the software, the actual assembling files, etc., all available. So if you want to start building a wearable solution, we got like reference design for that as well. So the board that we're using today is the NRF 51822 from Nordic Semiconductors. It's kind of the most used Bluetooth Low Energy chip that's out there. You're gonna find it in the Parrot drone. You're gonna find it in this little beacon. You're gonna basically find it anywhere. I got two of those with me. One is the 51DK that we see there, and the other one that I have is the BBC Microbit. The BBC Microbit is a little computer that's been given to all kids of age 10 and 11 in the UK last week. 1 million kids. So this is going to be part of their official primary school education. Yes, very cool. 1 million kids are going to learn how to program as part of their official primary school education program. That is, I would have loved that when I was, younger. Pretty cool. If you want to program this thing, we have to do it in C and C++. Although it's not as scary as it sounds, I'll show you in a sec. The really nice thing is that by building it on Mbed, we already do something very well, and that is running it off the battery very efficiently. So if you want to run something for a year on an AA battery, you got a budget of 0.137 milliamps. And if you run this as a Bluetooth beacon, as a physical web beacon, we only do 0.02 milliamps, so we get like 7 years out of an AA battery. There's like a path to actual hardware, so this is one of the hardware things that I designed. If you want to know a little bit more about how to do PCB designs, or how you can actually go from a prototype on a breadboard to actual proper to a proper thing that comes out of a factory, talk to me like after this whole session because we're running a little bit out of time. So let's build some demos. The Russian dancing guy, guys. It's all right. So what I have here on the front, I'm gonna show this like on the screen in a sec. Is a NRF51DK. It's a development kit with a breadboard. Let me show you this really quick. All right. So I'm actually running an IP webcam on one phone, and then I can like show you guys a little bit what's happening here. All right. All right. So what we have here is a breadboard, which is like a solderless way of like adding components together, with a tricolor LED on it. And the tricolor LED has like a red LED, a green LED, and a blue LED in it, which you can control independently, and we can basically make any color that way. Now, what I want to make is like a lightning system. You know Philips Hue. These are the lights that you can control from your smartphone and make like all these kind of colors. Well, I wanted to make something like that. So let's do that. I plugged the development board in my computer. So it's currently on. The light has basically all the colors on, so it's a bit pinkish. So let's say that I want to start developing. So as I explained, we have services and characteristics earlier on. So if we want to, so the first thing that we want to do is make this a beacon that sends out a URL, so we can actually discover that there's a light around us. Because we built a bunch of libraries together with Google actually around Eddystone, setting up a beacon is literally 7 lines of code, so that's not really interesting. The most important thing is, let me make this a bit bigger, is that here I set the URL that I want my beacon to send out. Is this visible from the back? You guys have an extra screen there. Okay. So I have a URL and I have a name of this system. So it's a light system, but I can also call it whatever. Russian lights. You know, creative. So that's one. We need to like send out a URL. So what we're doing here. Then, as explained, we have these services and characteristics. So for a light system, we want to have a light service. And under that, we need a color characteristic. So here you define, I have a service ID of 7997, and then I have a character which is A432. You're basically free to choose this. And then whenever I see a write come in, so whenever someone says, hey, I want to set a new color, I get the data in. You don't need to understand it. It's a bit shifting. I get to read the green and the blue channel, and then I write to the red, the green, and the blue LED the new color. So let's build that. The nice thing is that this is just built in the web browser, and the board mounts as a USB mass storage device, like as a USB drive. So you don't need to install any drivers. Just plug in the board. So get it here. I flash the board, and now go back to the stream. All right, so here I have my phone. Almost. So the first thing that I want to verify is that I actually see a beacon. So we see focus. So we see the LED control 2000, which is the URL that I'm actually broadcasting. And the nice thing is that when I look into the NRF master control panel, I see my light system here, and I can connect to it. And in there you're going to see the service, 7997. And under there you see characteristics, and I can program it that way. Okay, so we verified that this thing works. Now we can write a simple web application to control this. So all this code is available on GitHub. Really easy. I'm also going to demonstrate it later in the expert zone. In here, we basically have the same service and the same characteristic because we want to interact with that. Now we can say to Chrome, I want to have a Bluetooth device that implements this service, that implements service 7997. Then I can connect to that, do stuff, and then use a little color picker that I have on my phone to actually control the lightning by writing stuff. Not going to dig through all the code, we only have half an hour here. So let's open Chrome here. Yes. So Google will now show that LED Control 2000 is nearby, which is correct. When I hit that, I get to my web application. I hit the connect button. So now it's going to search for devices around me. This is a little bug in Chrome that sometimes it doesn't show for the first time. Gotta love new stuff. So this is in beta currently. It's only behind the flag. I think Chrome has stopped the phone. Just proving it's not me. Damn, this is such a cool demo. How's the work? Ah, wait, I'm still connected here. Yeah, that makes sense. Okay. So here's the nice thing, I also have a backup video in case this fails. Oh yeah, here we go. Yeah. So it's now connecting, and now, woohoo! Color change. I was a little worried. So yeah, we created, and the code for this is in total like 100 lines. Good stuff. What we can also do, because I'm really getting out of time right now, similar, we can do this with an accelerometer, which is on the microbit. And based on that, we can read that data of the accelerometer and then plot that into a graph. And I can even do that on my computer here. So now when I plug this one in, read the accelerometer data. And the accelerometer data measures, well, force, acceleration, downwards, upward, etc. So we don't even need to run that on a mobile phone. We can even run that in Node.js if you want to. So I'm going to put 2 of these here. That's going to be also the final show. It's going to read the characteristics. The idea is that then it plots it here, which apparently it doesn't. Hey, no one has said it's easy to do demos here live on stage. Okay. I'm going to show you juggling of phones in the, juggling of these things in the expert zone because I'm really running out of time. You can't do that. Anyway, what I want to say, you guys, is I'm hoping to have given you a little bit of an insight in what's going on currently in the whole IoT movement. We are seeing cheaper and cheaper and cheaper beacons. We see cheaper and cheaper hardware coming. We see Google currently investing heavily in this technology by adding physical web to Google Chrome. That's actually here that you can start using straight away. And also by adding now web Bluetooth to your browser, which allows you to discover and interact with devices straight away. And that's real fun. I mean, you know, for the longest time, I have been this developer that's always been looking at my phone all the time. That's always been thinking, how can I make this faster? I can make this nicer. I can make it more flashier. And then the first time that you use Bluetooth to blink an LED on a breadboard, you feel like this, you know, this 10-year-old kid that just like did like Hello World on a computer for the first time. And that's like the spirit that I'm so happy to get like back when I'm doing IoT. So just get some hardware, start hacking, and with that, I want to thank you all.
Am I right that I connect to Bluetooth device only once? One at once?
You can connect to a lot of devices, but yeah, one device can only be connected to by one other program.
It's a physical limitation, or we can deal with it with software?
No, so all the phones can detect like a beacon, but after that, if you want to connect to the beacon, only one device can do that at the same time. So only one device can control the beacon at one time. So you can't really work around that.
So maybe I'm kind of biased person, but first thing when I thought these beacons, I thought, oh, I can actually put these beacons everywhere in city and put advertisement spam.
Yes, no, but that's actually a serious concern also by Google at the moment. So one of the things they're trying to mitigate that is that they're going to work with blacklists. So,
like usual.
So at the moment, Google is like a resolver service. So you see like a URL, then Google will like go to the page, get like a little description and send it back. That's also where you can do the filtering. So Google's been thinking about it, but yeah, if this takes off, then that is a new problem that we need to take care of. Yes.
Yeah, thanks.
One here.
Hello.
Oh, sorry.
Thank you for speak. Now tell me please about embed. Does this thing work with Texas Instruments video processing devices?
It depends what the architecture is, but in general, at this point, we don't do business with TI with embed.
Okay, thank you.
Only ARM-based processors.
Hi.
Hey.
Maybe this is not a bit related to your speech, but my question is, what about privacy? For instance, beacons may be not just one-way communication, but two-way communication, obviously, and tracking users which are just walking around may be an issue. So, what do you think about it?
So, when it comes to so one, if you really want to track devices, Wi-Fi is probably better because Wi-Fi is more designed to be two-way, and if I have 3 Wi-Fi points around me, I can kind of follow people around the room already. With beacons, it's not like that. I mean, if a beacon is in beacon mode, if an actual sending mode, it only sends stuff out. So the phone can only get that. So a beacon cannot detect phones around it because it's not two-way communication unless the phone initiates that. So at this point, we can't use beacons to follow people around, for better or for good.
Okay, thank you.
Some person in the back or there. Yeah.
Hello.
Hi.
My question is about battery consumption on client devices. For example, in this case, it's on your phone. Does it require permanent Bluetooth scanning?
Yeah, and that was a problem. That was a problem in the past. But it doesn't really need all the time, only if your screen is actually on. But so this was a problem back in the days. Like when the Nexus 4 came out, about 2.5 years ago, this was still a big problem. The Bluetooth chipsets were not made to do continuous scanning. They were just like scan and then go to sleep. Companies like Broadcom that make the Bluetooth chips have done a lot of work on that. So the next generations, they got a Nexus 5X here. The next generation of Bluetooth chips in the phones do a lot better deal when it comes to power consumption. We're looking at that. So the hardware manufacturers are working on this, and yeah.
Am I right that when I will came across street where the Bluetooth beacon is placed,
yeah.
If I will not turn my screen on, I will not figure out that
Correct.
I have internet device.
Correct. I mean, it's also non-obtrusive. You will never get a push notification from a beacon. It's always like you pull out your phone, then you see, okay, there's 5 beacons around me, tap, then you'll see which beacons are there. So beacons will never like intrusively send you a push notification or anything like that. It's just for you whenever you want to do this. But
Okay.
yeah, only when your screen is on.
Thank you.
Hi,
Yeah.
thank you for talk. I'm a little bit pragmatic. How much does this toy cost?
How much does this what cost?
I mean beacon.
So
The minimal set.
Okay, so I bought a full one. I can give you the link after this, which contains this beacon, a battery, and a casing, and shipping. And those were $4 if I bought 100. So $400 for 100. So yeah, that's really cheap, actually, and we can probably go a little bit cheaper even.
Hey, any more questions?
I'll be at the expert zone, I think, after this. I'm also going to bring all the demos, including the juggling one, so you can see me throw stuff in the air there, if you want to play around with that.
Last question?
No. Okay, let's say thanks to Jan.